Hi.
This is a continuation of the 1-2 assignment. We wanted to pop back in on the habits of mind because we didn't finish up completely. How are the intercepts of a graph affected by the reflection across the x-axis? So when we left off, we had a nice little parabola, and then we might flip it over the x-axis. And this is a nice demonstration of how you can tell. The x-intercepts are not affected because 0 opposite it is still just 0. Whereas if this was, say, -5 or something, flip it up here and it's +5. So the y value has been changed to its opposite.
So just, we know that there are two types of intercepts. So in this answer, you should discuss the y-intercept as well as the x-intercepts. And in this case, you can see very clearly that those y-intercepts did change, but the x did not.
All right, so now we're moving on to example 3 about stretches and compressions. The first one just asks, and again, we're always just going to use f of x equals the absolute value of x as our home base in this, in all these examples. And this one's got a domain that's limited, so it's just the pieces. And they want to know what happens if you put a 2 in front of the function. So in this case, 2 times the absolute value of x. And then we're supposed to mention the domains and the ranges in that. So what they've done is graphed both. They don't show their work in here, but we thought maybe we should. So we were thinking if I was going to plug in the absolute value of 4, or sorry, the absolute value of -4 is +4. And then the way this looks would be 2 times the absolute value of -4. What does that equal? Well, you always do it, absolute value works as a parenthesis, so you gotta do that first. Absolute value of -4 is +4 times 2 is 8. That's where they're getting their 8. And a similar work for each of these. The way they showed it, we didn't want that to confuse you.
So as we're thinking about it, we're always going back to this absolute value, which is the distance x is from 0. We're remembering that that distance is only positive, and so that's where Mrs. Conway got her 4 times the 2. So that absolute value symbol is acting like a grouping symbol where we're going to do whatever's our f of x function first, and then we're going to apply that 2 times that whole function f of x. So we put a -4 in here, we did the absolute value, and that's how we got that 8.
And then graphing those points, so they've got the original points, the original graphed in blue here, and then when we multiply by 2, what you can see here is that each y value is doubled. Each y value is times 2. So 0 times 2 is still just 0, which is why you don't see that change, but for example, 4 times 2 was 8, and so that's how we're here. So what do you notice? This is a little taller, isn't it? And if it's taller, that's going to affect the range. So instead of going from 0 to 4 for our range goes from 0 to 8. And so that's what you see here.
In your notes packet, you can include the word stretch. And so as you're looking and working through that stretch, we're really affecting the range in this example, and it's a vertical stretch by a factor of 2.
And I think it's worthwhile to put the word vertical because later we'll talk about horizontal. So vertical stretch, everybody's going to know you're talking about up and down.
Let me see if I can clear this off for you.
All right.
We still have our f of x equals the absolute value of x. And so as we're continuing through this example, that is our parent function. We're looking at the same interval, and in this case, we're going to put the 2 within the parentheses. And so as you saw in our last video, we were talking about what happens horizontally here. And so, maybe my pen will work. We've got that original function.
The blue is the original.
I'm going to cruise up just a smidgen so we can see those. And I'll switch you pens for just a moment. So when we're thinking about this, we've got that -2. So when we put that in, we get 2 for our absolute value, and then we're going to double that. And so 2 times that -2, but we're taking the absolute value of that f, so that's how we're getting that 4.
So if I was to actually plug it in, it would be the absolute value of 2x. That's what our h function looks like. So I'm going to say absolute value of 2 times negative 2. Do you see how this is different? We're multiplying by the 2 first, which gives us negative 4. Absolute value of negative 4 is 4, and that's why we get this. And then, let me do another one just to be sure. So if I put in negative 1, it's the absolute value of 2 times negative 1. So and the last example, we were multiplying by 2 after the absolute valuing. And in this one, we're multiplying by 2 before we absolute value. And it does make a difference, you can see that. The order matters, and we're going to talk about that in the habits of mind as well.